decal, you do something complicated there. You run this code. You will wonder why when you see the dot method, everything looks fine until you get to the first open bracket, and then all of a sudden you get a lot of code. Well, that lot of code that comes there is because of that call, generate code there. And all that that does, you can see, is visit params. They don't have any children. So that just means it's in your generate code visit param decal that you put something in that you should not have put in. So all of that once you do is print out the signature, or else that will break. Oh, I hate when it says do something smart here. What do you reckon that is? Print return type signatures. Oh, yes, I know what the smart thing is. It was something to do with this. Maybe I should put some better comments in when I do this stuff. So you see, it just prints out. It prints out 50, and then it says md.locals used. So we have to set that locals used in visit method decal, but it's just being set to gender address. You call start method, except for when you have that main. Then call this start main method because I want a special signature, but I want it printed out with a Java length string. And if I don't do this and I try to run it with the Java virtual machine, the Java virtual machine will come back and say, sorry buddy, there is nothing to run. Because it always looks for a public static method called main that takes in an array of strings and returns void. So if it can't find that in the method that you tell it, or in the class file you tell it to run, nothing happens. Now if you want to run this in your EVM, then switch these two lines, or comment this line out and comment this one in, because the EVM will actually look for a public static main with no arguments. So there you go, and it also has a end method, and the end method looks a little long here. So that's because of another analysis that we are not going to do, but it's the what happens if you have a method that just falls off the end of the code. So if you don't have a return statement at the end, what happens?
Is it insert the return statement and stuff?
Well, what we do here is I simply just put one in at the very end of the code to make sure that we don't, jump off the bridge. Which means that when you actually code properly with your return statement, you'll see code that looks like that. Let's see, which one should we look at? Orders. Here, for example, this get position. You see, this is actually generated from code that you wrote or I wrote, and then this is inserted automatically. This code here never gets executed because when I hit this return here, I'm done. So I have this dead code here that was put in just because we actually didn't make sure in an analysis that we could get to the end, that we couldn't get to the end of the method without having a return. So all this does is as if looking at the type of the return type of the method, insert something that can return some default value, just so that we don't fall off the end of the code. But we could definitely do some sort of analysis. Again, it requires us to do the basic block stuff, which we'll talk about next week. And if you remind me, we can actually try to see if we can solve this problem. It should be fairly simple as well. Okay, I also have something here called data convert. And all that does is it converts between two primitive types. So if I have something that looks like this, if I say int a double b, and somewhere I have a plus b, remember that has to happen on the operand stack. Java is a stack-based language. So I got to put a on the stack, I got to put b on the stack, and then I have to issue a plus. Now let's say this is at address 1 and this is at address 2. Then I got to load a onto the stack. So that's going to be something load 1, and then I load 2. And then I add. Now, this is an integer, so I have to I-load it, integer load, and this is a double, so I deload it. Now, should I do an integer add, a double add, or what? Well, I better do a double add here. But now I have a problem with an integer and a double, so I better turn this integer into a double. And that's what that data convert thing will do for you. And you can actually call this one every time you have two things that must be of the same type, same primitive type, because they won't actually generate anything if they have the same type prefix. So if they're the same type already, then this just, you can see here, if the two type prefixes are the same, then it just returns, else it generates this thing with the, so it's safe to call that one all the time, because it won't actually generate any extra code for you. So I wrote that one for you. There's a load int, which loads an integer, constant, and there's some stuff up there that has to do with int and in hex and what have we not. But anyways, I turn it all into an integer value x, and then I switch on it. If it's -1, I can load -1 onto the stack by saying iconst underscore -1. If it's 0, I can say iconst 0. If it's 1, I can say iconst 1. If it's 2, I can say iconst 2, iconst underscore 3, iconst underscore 4, iconst underscore 5. Those are built-ins for those values. If I have a byte value, then I use bypush. If I have a short value, I use side push. I also use LDC. And instead of you every time you need to load a constant onto the stack have to go through and write that, you just call this one. Same thing if you need to load a long constant. Here it is. Load a float, load a double, load a string. If you need a label, you can get that. In order to print things to the file, you can call gen.print, or you can call it gen.println. So all that stuff is already there and can be used. So before you start this, just take a quick look through this file again, just to sort of get an idea of what's in here, so that you don't find that you have to write all this over again yourself. Especially some of this stuff at the very top, like define field and start method. If you didn't know it was in here, you'd probably be compelled to write that in this is method declare, this is constructor declare, and all that, and that's really not necessary because it's all there. So that gives you an idea of what things look like. And then there's the syntax for getting and putting fields and invoking methods is here as well. We'll probably come back to that next time. There's a list of signatures here, and also here's just a quick rundown of the generated classes we just looked at. Now, once I have these J files, I can, in theory, assemble them by saying Jasmine main.rj. So, I think if I say Jasmine, I think I have a Jasmine all. Did I write that? No. So, Jasmine here, .rj, Jasmine orders.rj, Jasmine object, Jasmine random. Is that it? And then I'm just going to compile this Java. See this file? I'll get back to that in a second. So now if I do that, I should be able to say Java main and say 5 and off they went. So that actually ran in the real JVM. Look, I said Java and main. Main came from assembling that RJ file. And that's actually pretty cool, I think, that we can get it running. So if you look at the output, you'll see J files when you run it. So if you run my reference compiler, you will get RJ files, and you can do diffs on those if you want to. Then you Jasmine all of them, and then you can say Java to whatever has the Java, so the static void main in. This IO guy is just a cheeky way for us to be able to do input and output, because Espresso doesn't support libraries and all that stuff. So what I did was I created see, I have this file or class here at the very top called IO that has a whole lot of nothing in it. it has print and print lines, and it has reads, but they don't do anything. So the reason that they're there is to make sure that if I want to do a io.print line, then the name checker and the type checker won't complain about these things not being defined. So they're here. They don't do anything, but the Espresso compiler really doesn't care much about that. What it will do, it will simply output this file here, which does absolutely nothing. So if I were to say Jasmine io.rj, I can do that, and then I say Java main now. You'll see that absolutely nothing happened. And that's because these prints and reads and whatnot do nothing. So what I do is I have this io.java file that has exactly the same class structure with exactly the same method, taking exactly the same things in, but now they actually do stuff. And now this is going to work fine because I'm going to compile this with the Java compiler. So now I get io.class generated by the Java compiler that contains the right stuff to do input and output, and now if I run main again, it'll work fine. So that's a nifty little way of actually using Java's library methods. The only thing is you have to remember to compile it. So what I would do is every time I compile something, before I have a little Jasmine, a little shell script that just takes all the J files in Jasmine. So what it does before it does anything else is deletes the io.rj, Jasmine's all the J files, and then compiles io.java. That way things will work just fine. All right, almost out of time. So there's some stuff about the IO stuff. It actually tells you here how to do it as well. Now, where do you start? Because this seems extremely complicated, right? You have to start somewhere. And where you start is with this class right here called small. And you make sure that when you call your compiler that it generates this output right here. So you get this from me, 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 you get this from me. You don't get this, you get that, and you get that. So simply by calling, or simply by creating a new instance of the generator, you get this. And by visiting any method, well, all the methods will get visited, right? So that's the default constructor. That would get put in there. So in your visit constructor decal, you need something that calls start method. So once you can do that, then now of course you can try to take the small class and say it extends something else or it implements something, just to make sure that that these things will go in here. But of course they will, because that's the code that I handed out to you. But let's assume that works. Then what? Well, then you take that and you try to put in a couple of locals, and then you try to do a little bit of assignment, maybe a little bit of if, and so on. So you sort of build on things you've already done. Don't try to do it all at once because it won't work. And the most important thing when you try to implement a code generator like this is keep in mind that if you can pass off a problem to somebody else, and I don't mean the guy you're actually implementing the code with, but some other method, then do so. So let's take a quick look at a couple of things that might seem complicated, but really isn't. So let's say I have something that says if some expression, then some statement, else some other statement. Then those statements could be blocks, they could be, I don't know these things. That expression could be something complicated, and what have we done? So what we have to do is we sort of have to think, here's the source code. That produces Jasmine code. And when that Jasmine code runs, it does something to the stack. So all those things I have to keep in mind at the same time. And that gets a little complicated, but it's very important that you try to do that. So what I always do is I say, okay, fine, let me look at the code segment and see how should the code for an if statement look. Well, we should have some code that evaluates E. And to make life easier, it doesn't generate the prettiest of code, but to make life easier, all Boolean expressions leave either 0 or 1 on the stack. If we do that, then it becomes a lot easier to program because then we can use actually these values as jump values. Okay, so here's the code for E. Here's my stack. How does the stack look after I've evaluated the code for E? I have a value there which is either 0 or 1. It will be 0 if the value of E is false, and it'll be 1 if the value is true. And I think Alex asked that question some time ago about what if that thing is not a Boolean value, but it is a Boolean value because the type check actually requires that to be a Boolean value, right? So there's no doubt about the fact that that it's a Boolean value. Another thing that's important when you write a code generator is everything has been checked. You know what you're holding is a parse tree that represents 100% valid program. There are no checks that need to be made anymore. We've checked everything that needs to be checked. Now we can generate the code. So now we have to sort of let go of the, oh, is this going to be right? Yes, because we've checked all of that. Everything you have is correct. So it'll do the right thing if you produce the correct code. Okay, so there's 0 or 1 on top of the stack. Now what should I do if it's the 0 that's on top of the stack?
Go to else.
Go to the else part. Okay. How do I check if I have a 0 on top of the stack? Well, now you've got to go dig in the Java Virtual Machine instruction set. But the one that we use is if eq. That removes the top of the stack and jumps if it is 0. And where do I want to jump? Down here somewhere. L1. So jump to L1. So now here should be code for S1. And let me just do that one in green. And this as well. That should say L1. L1. Now if I execute S1, it's because I didn't jump here. Then I certainly don't want to do S2, right? So I better jump around S2. So let me go to L2. Just move this one up a little bit. That was L1. That should be the code for S2. And that ends roughly here. And then I have L2. More stuff comes there, and there's more stuff there. So if you look at this code, oh, actually, if you don't mind, I'm just going to make a space here. Because all my labels are on empty lines, right? So if you look at this code, how much of that gets generated in the visit if stack? And how much of it is taken care of by somebody else? Well, what happens when I call visit on the expression? Well, I get code generated for it. That's this guy here. What happens when I call visit on this statement? I get code generated for it. That's this stuff. What happens when I call visit on this? I get code generated for it. It's that stuff. So all that stuff in blue here is taken care of by somebody else. That means that in visit if statement, or in the statement, your responsibility is all the stuff in green. That's 1, 2, 3, 4 things. So 2 instructions and 2 labels. That's really not all that bad. So always think in the following way. A call to visit will generate code in the J file, and when that code generates, it'll leave the right thing on top of the stack. So a call to visit on this will generate this code, and when that code runs, it'll leave the right thing on top of the stack. If you learn to think that way, this will be a cakewalk. And these, of course, are not called L1 and L2. They're the two next labels you get from the label maker. Okay, let's try another one. How about while E do S? Well, again, let's lay out the code. What should the code look like? Well, for as long as E is true, keep doing something. And when E is not true anymore, stop. So if I go and visit E, I would get code for E here. And when that runs, it leaves either 0 or 1 on top of the stack. If it leaves a 0, E was false. If E is false, then I'm done. So if EQ, L whatever, and I'll put L whatever down here. And then I just need code for S right there. And then I need to go back and do E, go through L2, and then we'll block in L2 right there. Okay, so how do I generate code for a while statement? I grab myself two new labels, print out the first one, visit the expression, print out if EQ, jump to the second label, visit the statement, print out go to L2, done. 5 lines of code, no problem. All right, let's try one that's more complicated. If you don't do these drawings when you write this code, you're never going to get it right. So just so you know. So for E1, E2, E3, S. A for statement sounds like something that could be complicated, right? But what's the rule for a for statement is execute E1, execute E2, or evaluate. If E2 is false, then be done with it. If it's not, then do S, then do E3, then jump back up and do E2. Okay, so just a little sketch says something like, E1 first, then E2.
Shouldn't you have a label between E1 and E2 to go back?
Yeah, possibly. We'll put those out in a second. Oops, wrong color. Now, if E2 evaluates the false, then I'm done. If EQ, L1, L1 is down here somewhere. If it was not done, then I will do S, and I'll do E3, and then I need to go back to the top and try one more time. And that L2 should be right before here. So there we go. So how much code did I have to generate for a for statement? 1, 2, 3, 4 lines of code, right? That's pretty darn simple. So we can do ifs, we can do whiles, we can do do's, we can do for with less than 4 lines of code for each of them, right? So this is really sort of magical. We don't have to do anything, but all of a sudden it'll all be there, right? So if I look at these skeletons for how to generate the code, and I go implement this, and this is sort of like a situation where you're like, I'm just going to ignore all this stuff in blue. I just have to remember to put the visits in. And if I put the visits in, whatever gets visited will do the right thing and generate the right thing and leave the right thing on top of the stack, and I'm good to go. Then of course, we find a way to get things onto the stack, and that's going to of course be in the name expression. The name expression is going to do a lot of the loading, so we get values onto the stack that we can work with. But see, it's actually pretty simple if you break it down like this. And we'll look at some of the other stuff. We don't have any more time now. We'll look at some of the other stuff here on Monday.
If you load the changes that you make to type checker.
Yes. I think so. So let's see.
Oh, I tried to do the patch thing, it never worked. I have to go ahead and
No, it
install
doesn't work. You still do it right.
Okay, well, probably. Most
You have to give it the you have to give it the address of the name of the directory you're patching with.
Oh, the actual name. I thought you had to give it the face number.
No, you give it the because you have many directories. Yeah, you have to give it the name of the directory you want to patch from.
I thought it was you give it the face number and it goes.
No, because you can patch many times. So you can patch back from if you screw something up. So /espresso. I can move that up. Hold on.
Oh yeah.
So espresso R and 4 or 5 4. No, I'm just gonna do what do you need it for? You need it for phase 5?
Yeah, otherwise it crashes that thing.
Well, you don't want to do it that way. You want to do it my way anyways.
Good luck.
Don't use the target type. Use target method.
Okay, yeah.
Because using the target type is going to happen. You're going to get into a whole lot of trouble anyways.
But don't I need it the
No.
changes that you
No,
made?
no. Those were just nice and cosmetic.
Okay. Fair enough. Okay, then it doesn't matter then.
No, no. I'm just going to put J6 on there. No, that's nice. Because I know you're going to be sorry.
Yeah, I'll try. Does anybody have gotten the phase 4 grader already?
Does anybody have what?
Phase 4 graded?
I don't think so. I guess I haven't looked for it yet, though.
Well, mine hasn't yet, so I don't know. I was wondering.
Let me send you those notes. Sure. Okay, it's not that much. Yeah.